Okay, problem 19.2. We're given a series of scenarios where we have a B field and we have a proton with a velocity moving through the magnetic field, and we're asked to find the direction of the force on the proton. Okay, so we have a proton moving through a field. This indicates, these x's indicates, if you think of this as an arrow, the field is pointing into the page, right? It's pointing at the page. This is the back of the arrow. That's how I remember it. And so we also have our force law, V cross B. I don't know if we know about cross products in the algebra courses, but I do know that we know V B sine theta. And so this is equal to this, right? These are the same thing. And so what this means is that you can use your right hand rule to figure this stuff out. So we have a velocity, we have a B field. So then we point our fingers of the right hand, remember this is the right hand rule, along the velocity. Then we find a way to curl our fingers towards the B field. So I'm going to be pointing my fingers straight along the page and then curl it into the page. That means that the force is moving to the left. So this is moving, the force is moving this way. Okay, next, move this out of the way. Do the next one. Same thing, I point the fingers of my right hand along this velocity, and then I find a way to curl my fingers towards the yellow lines, which are the B field, and that means that this is going to be pointing into the page. The force is pointing into the page. Right? Remember, this is indicative of these x's here, where we're pointing into the page. Okay, do the same thing. Keep going. So point fingers of the right hand to the left, find a way to curl them downwards, and this is going to be pointing out of the page, towards you. That would be indicated by something like these little dots. Right? These dots. The force is pointing towards you. Okay, next. This one, again, find my right hand fingers pointing to the left. Find a way to curl them upwards, so my palm is up. That means that the force is going to be pointing along this direction along the page, towards the top of the page. Okay, next one. Following my right hand, this is the velocity, right hand fingers point along this way. I need to find a way to curl the fingers this direction, so point and then curl. That means it's going to be pointing into the page. Again, into the page. We point our right hand fingers this direction and then curl them towards point and curl. That means it's going to be pointing straight out of the page. And then so for the electron is just the negative version. As far as charge goes, the electron is the negative charge of the proton. So what that means is in this formula that you have, this is Q for proton, this is Q for electron. We have Q times V cross, VB sine theta, right? So what this tells us is if this is the magnitude times some direction, r hat, times the charge, then for an electron, this is a negative charge times the magnitude times the direction, which indicates that it is exactly the same, but in the opposite direction. So the whole point that I'm trying to make is for an electron, it's going to be going the opposite direction for all of these. So for this one, it's into the page. This one is out of the page. This one is downwards. This one is in the page. This one's out of the page. This one's to the right. Okay? For all of them. Great. Next one. Next one for number 3. We're given 3 scenarios where we have a force and we have a velocity of a particle. I'll just draw all 3 real quick. This is, in the book they have it looking like that. Okay, and then the last one is this way. And we have this way here. Okay, so that's V, 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 F, F, F. Okay, and what it's asking us is to determine the direction of the magnetic force on it as it, no, that's not right. Find the direction of the magnetic field, that's what it's asking. Find the direction of B. Okay. Well, recall that we have this, and we have a cyclic scenario. So what that means is that I can take this term over here, shoot this one in here, is going to equal, just ignore the charge for now, F cross V. And so what that's telling me is that I need to use the right-hand rule again. Use the right-hand rule. Okay, so we're going to take F cross V. So all I'm saying is that we're going to point our right-hand fingers along F and curl them towards V, and then try to figure out which direction the magnetic field is pointing. So if we do, so point, curl, that means that it's pointing into the page. The B field is pointing into the page. Now we point along this way and curl upwards towards us. So we point and then curl upwards towards us. That means that the B field is pointing to the right. I'm just using the right-hand rule for all of this. Now we point along to the left and curl it into the page, which means it's going to be pointing. So if we point along this way and then curl downwards into the page, our thumb is pointing to downwards along the page, this way. So that's how we would do those problems. Whether or not you are familiar with this, you can still just use the right-hand rule whenever you approach a problem. Okay.